Hello everyone. In this video, I'm going to draw Lewis structure of 10 covalent compounds. I think it would be enough 10 examples if we review step by step. And in another video, I'm going to focus on Lewis structure of ions. So in this video, we are going to focus on only covalent compounds. So to remind you, when we are going to draw Lewis structure of compounds, we need to work on total valence electrons, bonding and non-bonding electrons in the compounds. So I'm gonna start with working on CHCl3. I'm gonna focus on Lewis structure of this one. So first one, I'm gonna know how many total valence electrons for this one. So I'm going to write that 4 because carbon group number 4, hydrogen group number 5, and we have 3 times number of chlorine is 3 times the valence electrons of chlorine 7. So this number, if we calculate that, we are going to have 26. Then we have bonding electrons for this one. When we are going to find the number of bonding electrons, we need to have a first form or draft for the compound. So H and 3 chlorine, so nobody is going to put the hydrogen as a central atom. Please understand, always we have carbon atom as a central atom, hydrogen here, or you can add chlorine on the top, left, and bottom, or any other combination for the terminal atoms. Then for bonding electrons, you just need to connect the central atom to each terminal and then count number of electrons. Each bond means 2. So I'm gonna write it here for you guys to remember the meaning of bond. Each bond means 2 electrons. So 2 electrons, 4, 6, 8. So I used 8 valence electrons as bonding electrons. Non-bonding is coming from this calculation, 26 minus 8. So we are going to have 18 valence electrons here. We do add 18 valence electrons as pair electrons to terminal atoms, except hydrogen. We do not add to the hydrogen because it's going to have duet rule. So 6 electrons should be added because each one has 2 bonding electrons. So let me write like this. 2, 4, 6, 8, 10, 12, 14, 16, 18. No more electrons left. So if we have any electrons left, we should add to the central. But all 18 electrons already used. The only thing you should do at the end, you need to count number of valence electrons for the central atom. Our central atom, I'm sure you are going to say that it has 8 valence electrons. So this is the Lewis structure of CHCl3. It would be same if I ask you to work on SiF4. So I'm gonna focus on this one. Again, please write TBN, and I'm going to work on drawing SiF4, silicon tetrafluoride. So I'm sure you are going to pause the video, and after that you are going to double check your answer. So total valence electrons, Si group number 4 and fluorine group number 7, but we have 4 fluorine atoms. So I multiply by 7 times 4, 28 plus 4, 32. So 4 fluorine times 7 because each fluorine has 7 valence electrons. Then I'm going to write Si and 4 fluorine atoms here. Here, I'm gonna make a connection between the central and each terminals. So, like this one. 2, 4, 6, 8. 8 valence electrons already used, so I'm gonna add only 24 valence electrons as non-bonding electrons to this compound. I subtract 8 from 32. 24, no hydrogen, so we are going to add 6 electrons to each element here. So you just need to count 24 electrons already added. So our central atom should be follow the octet rule. Let me count. 2, 4, 6, 8. So we do have 8 valence electrons for that one. So this is the Lewis structure of SiF4. Let me work on a little bit different by these examples. So I'm going to focus on H2S. H2S. So let me write TBN. So number of valence electrons for hydrogen is 1. We have 2 hydrogens plus 6 for sulfur. We totally have 8. So let me write S and hydrogen on the left, hydrogen on the right. And we are going to have, or let me say something like this. So hydrogen, 2 bonds here, it means 4 electrons. 1, 2, 3, 4. Each bond means 2 electrons. So I just use 4 electrons here. So 8 minus 4, we have 4 valence electrons left. There is hydrogen as a terminal atom. So there is no other terminal atoms. We do not add to the hydrogens. So for electrons, there is no more terminal, so we have to add to the central atom. 2 on the top, 2 on the bottom. So we are done with adding non-bonding electrons. You just need to look at the central atom. 2, 4, 6, 8 valence electrons for sulfur. It's going to obey octet rule. And for hydrogens, we have to. This is Lewis structure of H2S. Let me work on OF2. OF2. Let me write TBN, total valence electrons. I'm sure you watched the video after solving this one and drawing OF2. 6 plus 2 times 7, so 14, and 6 we have 20 electrons. I'm gonna draw oxygen as a central because we have only 1 oxygen and 2 fluorine atoms. Then we are going to connect the central atom by single bonds to terminal atoms. 2, 4 minus 4, we are going to have 16. Wow, too many electrons. Let me add 2, 4, 6, 2, 4, 6. I use totally 12 valence electrons here. 2, 4, 6, 8, 10, 12. 14, 16. We add to the oxygen as a central atom. Then, when we are done, we are going to count number of electrons for central, only central, because we know that terminal atoms, they follow octet rule. So let me count. 2, 4, 6, 8. So we totally have 8 valence electrons for oxygen atom as well. Let me work on another one. Another pair of compounds I'm gonna share with you, like CO2. Like CO2. So let me write TBN, carbon group number 4, 2 times 6. Totally we have 16 valence electrons. Let me draw carbon, oxygen, oxygen. Then we are going to connect the central atom by single bond. So minus 4, 2 and 2, 4. And we are going to have 12 valence electrons left. We add 6 electrons to the terminals, 5 pairs. Please look here. I need to count, I'm done with adding, I need to count number of valence electrons for carbon. So I'm going to count 2, 4. It doesn't have 8 valence electrons. So we need to make 8 valence electrons for carbon atoms. To do this, you need to remove two valence electrons from the terminals and make a bond here. So I'm gonna remove from this and make a bond here. Right now I'm gonna count number of valence electrons for carbon. 2, 4, 6. 6. We still need to have more electrons for carbon. So same scenario, you need to remove two electrons and make a bond. Right now, as I said, we prefer to have a symmetric compound. I'm going to remove two valence electrons and make a bond here. So right now 2, 4, 6, 8. 8 valence electrons for carbon. So CO2, if we are going to do some study in by experimental point of view, we will find CO2 has like two double bonds. So if you want to remove the second time pair electrons from this oxygen, you make triple bond and single bond. But when we do research and study CO2, we will find CO2 has like this form. So we say that we prefer to have asymmetric compounds. And absolutely, we have some equations to confirm that one. We call that formal charge I don't review that one in this video. Let me work on another example here, similar to this one. I'm gonna work on COCl2, TBN. So 4, 6, 2 times 7, it gives us 24. Carbon and oxygen, carbon is going to be central, oxygen, and we have two chlorine atoms here. Then make a bond between central and each terminal. 2, 4, 6. I say minus 6. So we are going to have 18. I need to add 18 electrons to the terminals. No hydrogens, so I can easily add 6 electrons to each one. So as you see here, I used all 16 electrons and 2 electrons left. 2 electrons left. So I'm gonna make like this. 2, 4, 6, 8, 10, 12, 14, 16, 18. Sorry. 2, 4, 6, 2, 4, 6, 8, 10, 12, 14, 16, 18. I used all 18 electrons here. So sorry for my mistake. So 18 electrons we already added. Right now, I'm gonna count number of electrons for all carbon atoms. For carbon atoms. 2, 4, 6. 2, 4, 6. So right now, we need to remove two electrons from terminals. What terminal? We may say right now, this is a note. We may say halogens in general make single bond. Single bond. So let me write single bond like this. Whenever we are going to work on the single bond, so please remember that single bond, they already have. So I'm going to focus on oxygen. So this is a rule. If we have halogens, halogens prefer to have single bonds. So we do not remove electrons from halogens. So I have to remove electrons from oxygen. I remove two electrons from oxygen and make a bond. So 2, 4, 6, 8. So carbon atoms 2, 4, 6, 8. Right now we have 8 valence electrons for carbon atom as well. So there are another two examples that you already watched in this video. And I'm gonna work on the last two examples. Right now, the two examples that I'm gonna work on and a pair of examples at the end, they are going to work on another concept. I consider that one for you guys. This one, NO Cl. How about this? TBN, nitrogen 5, oxygen 6, chlorine 7. So we have totally 18 valence electrons. One question, which one is going to be the central atom? So I told you the element on the left side. So nitrogen, oxygen, Cl. So you may write nitrogen as a central atom because on the left side of the periodic table it has more metallic properties. Then make a bond between the central and terminals, -4. So we are going to have 14 valence electrons. We add 6 valence electrons to each terminal. So I use 12 valence electrons. 2 electrons left, I'm going to add to the nitrogen. Then we need to count number of electrons for the central atom. 2, 4, 6. 6 valence electrons. I need to make 2 more electrons. Again, if you have halogens make single electrons. Single bond. Make single bond. Make single bond. So we do not change halogens. We work on another terminal. Oxygen, I remove electrons and make bond here. So let me erase here. Count number of electrons for nitrogen. 2, 4, 6, 8. So right now we have 8 valence electrons for nitrogen. And let me work on this example here. PF3. TBN, phosphorus group 5, 3 times fluorine 7, 26. Let me quickly draw that. P, F, F, and F. Central should be connected to the terminals. So I use 2, 4, 6, -6. Totally we have 20 valence electrons left. 6 electrons to each one. I used 18, so I'm going to add 2 electrons here as 20 electrons non-bonding reported here. Right now, we count number of valence electrons for phosphorus. 2, 4, 6, 8. So it looks we don't need to add any electrons borrowed from the terminals and add to the central atom. I ask you to please pay attention to last 2 examples. I'm going to focus on one concept for Lewis structure drawing. We are going to work on SO2. SO2. Let me write TBN. So group number 6, 2 times 6. Totally we have 18 valence electrons. I'm gonna write S and 2 oxygens here. I'm gonna make a bond between terminal and central atom 2 and 4. So I'm gonna say I used 4 bonding electrons here. I subtract to find 14 non-bonding electrons. So I add 6 electrons to each terminal because we don't have hydrogen. I used 12 electrons, 2 electrons left, I add to the central. Right now I need to count number of valence electrons for central. 2, 4, 6. I can borrow electrons from terminals. It doesn't matter what oxygen you are going to pick, oxygen on the left or oxygen on the right. I'm gonna remove electrons from oxygen on the left and make a bond here. So 2, 4, 6, 8. So I have 8 valence electrons for sulfur. If you say that I'm going to have oxygen, sulfur like this, and you are going to say that you're gonna remove 2 electrons from this oxygen and make double bond. It would be same. There is no difference between the oxygen atoms. Both oxygen are identical. on the left, on the right side, so you can draw like this one. So if we look at the SO2 in the real chemistry world, we will see that SO2 has these two structures. One structure, it means if the sulfur atom has double bond with the oxygen on the left, another one oxygen with the right side make double bond with sulfur. If we have this possibility, please pay attention. If you have this possibility to make multiple bond, like double bond, by same atoms, you are going to have resonance structure. One more time. You have this possibility to make double bond for sulfur and oxygen atom, either oxygen on the left or oxygen on the right. At this time, you may have both structure. We call that resonance structures. So resonance structures, they are compounds when we have double bond between the same atoms and the central atom. So you have two oxygen, so you may have double bond either on this oxygen or that oxygen. Whenever we have resonance structure, we denote the resonance structure by this notation. So it means the SO2 Lewis structure has either this one or that one, that Lewis structure. Let me work on another example, like SES2. Let me write TBN. So I'm going to calculate that. Selenium group number 6 plus 2 times 6. It looks we have 18. So I'm going to write Se here as S. So I'm going to make a bond between central and each terminal. We are going to count number of bonding electrons, 4. So we do have 14. I'm going to add 6 electrons again and 2 electrons on the top. Look at the central atom. It has only 6 valence electrons. Right now, you have this opportunity to remove 2 electrons from sulfur on the left or sulfur on the right. It doesn't matter which one. So I'm gonna write that one more time. To make sure you understand this one. So this is our structure. I'm gonna remove 2 electrons from sulfur on the left and make a bond, or I can remove 2 electrons from sulfur on the right and make a bond. So I erase this one. If we count sulfur electrons 2, 4, 6, 8, and for selenium we have 2, 4, 6, 8. Sulfur 2, 4, 6, 8. So we do have 8 valence electrons for each one. It would be same for selenium on the right side, 2, 4, 6, 8, and other sulfur atoms as well. So we are going to have resonance structure. So I could draw resonance structure here. But please pay attention, we prefer to have resonance structure if we have this opportunity to remove electrons from the terminal atoms, either sulfur on the left or sulfur on the right. On the next video, I'm gonna focus on the resonance structure and polyatomic ions. I'm gonna work on some examples of polyatomic ions Lewis structure as well. Thank you for watching this video.